Alright, so in this section we're going to be taking a look at another aspect of Lewis structures, which is something known as resonance structures. So when we discuss resonance structures, what we are referring to are equivalent ways to represent a Lewis structure. So in some cases, according to the rules of drawing Lewis structures, you actually may be able to draw a couple different structures that both still follow all the rules of drawing Lewis structures that we talked about before. So when you're able to do that, we call those possible structures that can be drawn, we call them resonance structures. So in that case, the true structure is not really either one of those. The true structure is actually just a hybrid between them. But in the absence of that hybrid, we can draw either one of those resonance structures, and either one of them would be correct. So let's take a look at an example. And as an example, we're going to take a look at an ion, a polyatomic ion. Which is carbonate. Okay, and this is one of the polyatomic ions that you had to know for your previous exam. So the carbonate ion has the formula CO3 with a -2 charge. So when we go through the steps for drawing the Lewis structures, the first thing that we need to do is to count the number of valence electrons. So we have one carbon. Carbon is in group 4. So 1 times 4 would give us 4 valence electrons for that C. We have 3 oxygens. Oxygen is in group 6, so 3 times 6 would give us 18. So that gives us 18 plus 4, which is 22. And when you have an ion, remember, we take into account that charge, right? So when you see that negative charge, that actually means we need to add that many electrons to our valence electron count. So we're going to add 2 electrons to it because our charge is -2, telling us we have 2 extra electrons. So we add them and we end up with 24 valence electrons. So when we draw our final structure, we should have 24 valence electrons in it. All right, so that's our electron count, our valence electron count at the beginning. The next thing would be to orient our atoms. When you see carbon in a structure, you just go ahead and stick it in the middle right away. Okay, so C goes in the middle, and then the O's will go all around. All right, so you have our 3 oxygens around. We're going to connect everything so they don't fly away. Okay, so that's the glue. That covalent bond there is the glue that sticks those atoms together. And then we're going to give these outer atoms enough electrons to account for their octet. So this oxygen here on the right side, it needs 6 more to complete its octet. The oxygen on the left side also needs 6 more. And the oxygen on the top also needs 6 more to complete its octet. So we've made the atoms on the outside, we made those oxygens happy with their 8 electrons. So let's count and see how many total electrons we have in our structure now. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so those are our 24 valence electrons. We've made the oxygens happy with their octet, but if you notice the carbon in the middle, right, it only has 6 electrons around it, right? The 2, 4, and 6. So it actually needs 2 more electrons. But we can't add any more electrons to our structure because we already have our 24 electrons. So the only way to fix that would be to move a lone pair of electrons in to make a double bond. So we can, for instance, take this lone pair and move it in here to make a double. So then we would end up with a double bond between the carbon and that oxygen on the right side. So now this oxygen here on the right still has its 8 electrons, and now the carbon in the middle has 2, 4, 6, 8. So now the carbon's happy. We didn't add any more electrons to this, so we still have our total valence electrons. So this would be a possible Lewis structure for the carbonate ion. Remember, when you have an ion, you also need to include the charge on it. So we're going to put this in square brackets, and our charge is -2. Right, so that's one possible Lewis structure. Now, what you will notice is that, well, I moved my lone pair from this oxygen over here on the right, but could I have moved the lone pair from the oxygen on the left side? Or maybe from the oxygen on top? It didn't really matter where I moved that lone pair from, right? So for example, if I had moved that lone pair of oxygens from the top atom, I would end up with a double bond at the top now. Now I'd have 4 electrons left, and then I'd have my remaining oxygens and 6 electrons around them. This would also have a charge of -2. And then I could also have moved the lone pair of electrons from this oxygen here on the left side. And in that case, I would end up with a double bond on the left. And then this would have a charge of -2 as well. So all 3 of these, because they all follow the rules for drawing Lewis structures, right? They are all acceptable structures for the carbonate ion. So we refer to all of them as resonance structures. For CO3, for the carbonate ion. And the way that we show that these are resonance, and you'll probably see this in your textbook as well, we use an arrow that goes with 2 heads to it that points both ways. All right, so in some cases you'll come across, I think your book does a good example of going through how you draw the resonance structures. This is another example here using the carbonate ion of where that can happen. And again, what these resonance structures are, they're just equivalent ways to represent your Lewis structures that still follow all the rules for drawing Lewis structures. We can take a look at another example. Let's look at the Lewis structure for nitrate. So the nitrate ion, which is another polyatomic ion, NO3 with a -1 charge. So we do our valence electron count. We have 1 nitrogen. Nitrogen is in group 5, so that'll give us 5 electrons. We have 3 oxygens. Oxygen is in group 6, so 6 times 3 is 18. 18 plus 5 is 23. And now we have our negative charge here. We're going to add that in to give us a total of 24 valence electrons in your structure. All right, so we have 1 nitrogen and 3 oxygens. In the absence of carbon, nitrogen likes to be in the middle, so we have N, and then we're going to stick our oxygens around it. We have 3 of those. We're going to connect them so they don't float away. Then we give the outer oxygens enough electrons to complete their octet. So each of those oxygens right now has 2 electrons, so they each need 6 more. So we have 3 lone pairs of electrons around each of them, and then we do a quick check. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Those are our 24 valence electrons. All right, all the oxygens are happy because we made them happy at the beginning. The nitrogen, though, right now only has 2, 4, 6. So just as in the previous example, what we can do is we can move a lone pair of electrons from any one of these oxygens. I'm going to pick the one on the top and move it in. So I end up now with a double bond between that oxygen on top and the nitrogen. So now the N has a total of 2, 4, 6, 8 electrons. So it's happy. The oxygens are already happy. We have our 24 valence electrons. This was an ion, so we put it in square brackets with our -1 charge. So that would be an acceptable Lewis structure for the nitrate. I could have just as easily have moved this lone pair to make a double bond over here. I could have moved that lone pair to make a double bond there. And if I did, okay, then I would end up with my other two resonance structures. So I could end up with a double bond on the right side, the -1 charge, and I could also end up with a double bond on the left side. And this has a -1 charge as well, right? So these are all resonance structures for the nitrate ion. So they are acceptable ways to draw the Lewis structure. We have multiple ways, multiple acceptable ways to draw the Lewis structure, so then we refer to those as our resonance structures.